Hello everyone. Today we have a new problem. Let x and y be real numbers such that x and y are positive. Show that x to the fourth plus y to the fourth over x plus y is greater than or equal to xy to the 3/2. Okay, you can, as usual, pause the video and give it a try. Let x be positive and y be positive, real numbers of course. We're going to proceed with equivalences. So we'll show that this inequality is equivalent to another inequality that is true. Since they're both equivalents, the first inequality will be true. So we start with x to the fourth plus y to the fourth over x plus y is greater than or equal to xy to the 3/2. That's equivalent to, so since we won't forget that everything here is positive, so x and y are positive, so all these numbers are positive, so we will multiply both sides by x plus y, and so we have x to the fourth plus y to the fourth is greater than or equal to x plus y times xy to the 3/2. Now, in order to remove this half in the power here, we will square both sides, and we have the right to square both sides since everything is positive. So x to the fourth plus y to the fourth all squared is greater than x plus y times xy to the 3/2 all squared. But then ab to the n is equal to a to the n, b to the n. So this is equivalent to, I'll expand this square here, so we have by the binomial formula, so it's x to the fourth all squared plus y to the fourth all squared plus 2 times x to the fourth y to the fourth is greater than, again here we have this, we use this law here, so we have x plus y squared times xy to the 3/2 all squared. So here we have x to the 8th, since a to the n all to the m is equal an times m. So here we have 4 times 2, that's 8, plus y times 2 the 8th, 4 times 2, plus 2 times x fourth y to the fourth is greater than. We'll expand this one, and that's x squared plus y squared plus 2xy times x y cubed times xy cubed. Using the same one, 3/2 times 2, and we cancel the 2. So again, it's 8 y to the 8th plus 2 times x to the fourth y to the fourth is greater than, and we will expand everything here. So this one is x cubed y cubed, so it's x cubed y cubed. So x squared times x cubed times y cubed, that's x to the 5th y cubed, plus y squared y cubed, that's y to the fifth times x cubed, of course, plus 2 times x cubed, that's x fourth, y cubed, that's y to the fourth. Of course, we have the ability to cancel those two because we can just subtract the same number from both sides and it will cancel. That gives us x to the 8th plus y to the 8th minus, or bring everything left in this right hand side to the left hand side, so minus x to the 5th y cubed minus x cubed y to the 5th is greater than 0. So all we need to do now is to show that this number is really positive or equal to 0. So what we'll do is to rearrange this sum. So it's x to the 8th minus x cubed, x fifth y cubed plus y to the 8th minus x cubed y to the 5th. And here we can factor the x to the 5th, so x to the 5th. So we have a x cubed minus y cubed, okay, plus y to the 5th, so y cubed minus x cubed. We can have this remark that this number and this one are all opposite numbers. So a minus b is the opposite of b minus a. So we can write it like this. So x cubed minus y cubed minus, so we replace this number with minus x cubed minus y cubed times, of course, y to the 5th. And here we have a common factor, which is x cubed. So it's equivalent to x cubed minus y cubed, which is the common factor. So times x to the 5th minus y to the 5th is greater than 0. Again, we can see clearly that these two numbers have the same form, x to the n minus y to the n, with n, of course, an integer greater than or equal to 2. So this is equal to x minus y times the sum from I equals 0 to I equals n minus 1 of x to the I, y to the n minus I minus 1. So we'll factor this one, so x minus y times, this is the first one, x squared plus xy plus y squared times the second one, factor x minus y times, so it starts with x to the 4th plus x third, x cubed y plus x squared y squared plus x y cubed plus y to the 4th, of course greater than 0. This is equivalent to, so x minus y times x minus y, that's x minus y squared times the other numbers, so x squared, x plus xy plus y squared, okay, y squared times all this sum, so x cubed plus x cubed, x to the fourth, plus x cubed y plus squared y squared plus xy cubed plus y to the fourth is positive. But this inequality is true. Why is it true? Because this is a square, and the square is positive, and this is the sum of positive numbers, positive real numbers, since x and y are both positive since the beginning. So this is sum of three positive numbers, and here we have the sum of 5 positive numbers, so positive. So this is positive. So the product of positive numbers, and this can be equal to 0 if x equals y, is all true. So since we have the first inequality is equivalent to this last inequality, which is true, then that means by equivalence, of course, we have that we deduce that x to the fourth plus y to the fourth over x plus y is greater than xy to the 3/2, which ends our proof. Thank you very much for watching, and I hope to meet you in the next video.